All right, now, so we have a lot of words right here, and I think we can put some check marks on the stuff that we already knew. Would you say that you know how to factor? Right? Let's go ahead and check it off. And by the way, I hate this page. I hate this page. I didn't make this page. But why would I hate it? Let me tell you why. Now, if you look at this page, it seems like you have an order of operations. Step 1, step 2, step 3, and I will tell you this, or you may want to write this down actually. There's no order. You can do whatever you want to. You want to find out the asymptotes first? Go ahead. You want to find out the intercepts first? Go ahead. There is no order, okay? So please do not follow these orders, okay? They are just, you know, a reminder, okay? I would say just reminder. Would you say you know how to find out the y-intercept? Which is y-intercept is always 0 comma something, right? So therefore you put 0 into x. If you know it, go ahead, put a check mark next to it so that you don't have to worry about it. Do you know that finding the x-intercept means that you have to get y equal to 0? Yeah? Okay. And since we're dealing with fractions, I would like to add just one little thing about fractions. For a fraction to equal to 0, what must happen? Okay, for a fraction to be 0, the numerator must be 0, and we will see some of those in the future. Okay, for a fraction to equal to 0, the numerator must equal to 0. Okay, so now, and the other reason, my second reason that I hate this page is that if you look at all these words on this page, it only tells you what to do and it explains nothing. And if you know me well, I love to explain stuff. I need to know how it works. And this page explains nothing. So that's why I hate it. All right, step number 4. Vertical asymptotes. I've said it for quite a few days now, for last 2 days. Now, if there's a word that you want to closely associate it to a vertical asymptote, the word would be, do you remember what word would be, should be closely related to, associated to a vertical asymptote? Undefined. Okay. You want to reduce them. You want to reduce the concepts. You want to make it simple. This is how simple it could be. What is vertical asymptote? Why do we have vertical asymptote? Well, because something becomes the function becomes undefined, and since we are dealing with fractions, that's why we consider the denominator, the possibility of the denominator becoming 0. And then look at step number 5. Now, for number 5, I'm going to put a question mark because I am not confident that you know what's going on with horizontal asymptote. Can anyone tell what relates to horizontal asymptote? Like if you think about horizontal asymptote, what should you be thinking? Could be, but not pinpoint enough. What must you be thinking when you think about the horizontal asymptote? The meaning behind horizontal asymptote. And I said it before, that if you don't understand what asymptote means, if you don't understand the definition of vertical and the horizontal asymptote, then you are just going to memorize it, and this would be miserable. Horizontal asymptote, it's about when x becomes infinitely large. And then we ask the question, what is the y value? Okay, what is the y value? What is the y value when x becomes infinitely large? Okay, what is the y value when x becomes infinitely large? If you know it, great. If you don't know it, now is the time. Now it's really the time. Now everything has a story. All right, you have to understand what is the story behind the horizontal asymptote. If you just go ahead and memorize, yeah, that thing, it will not end well. Okay. Now again, the key idea is x becoming infinitely large. So we talked about this before. If you have 2 divided by infinity, that it's practically 0. Okay. Now, what about x over x squared minus 4? The thought process that we had a couple days ago was that when you have x squared, which it's going to be a huge number, like infinitely large, and then you subtract 4, you minus 4. What would that be? What is infinity minus 4? It would still be infinity, right? So we can reduce this to x over x squared. And then you can simplify this to 1 over x. And therefore we say, hey, what is 1 over x when x becomes so huge, like infinity huge? Then we say, oh, 0. So now, if you understand what just happened, okay, I hope the following statement will make some sense. And that is, when the power of x, okay, when the power of x in the denominator, okay, when the power of x in the denominator is greater than the power of x in the numerator, okay, so 1 over x or x over x squared could be just 2 easy examples. Then the horizontal asymptote would be y equal to 0, because that's how it happens when x becomes a huge number. Okay. Now, and this is the reason why I kind of dislike this statement right here, because I don't like this statement. I like the one here better. Okay, I like the one here better. The power of x, which is the word degree. Okay, the power of x in the denominator is greater than you have y equal to 0 as your horizontal asymptote. Again, people are going to memorize this, and you shouldn't. You should understand why, because you're thinking about horizontal asymptote is when x becoming infinitely large. Okay. Now, what happens if they're equal to each other? If the powers are equal to each other? Now, let's think about this. Okay, easy stuff. Now, if there are, well, let's look at this. Would the minus 3 matter? When x is like huge, would the minus 3 matter? We say, not really. You have negative x squared, all right? So if you have x being infinity, so infinity times infinity, it's going to be a gigantic number. And this is x, which will become infinity. But if you compare this one with this one, they are not really the same. This infinity square is going to be much bigger. So this one, kind of scratch it off. So you can reduce this into 2x squared over negative x squared, okay? Because the addition and subtraction, they're just not impactful enough to change the reality. And then when you have 2x squared over negative x squared, what could you reduce this into? 2x squared over negative x squared. What could you reduce this into? 2x squared over negative x squared. What could you reduce this into? 2x squared over negative x squared. What could you reduce this into? 2x squared over negative x squared. What could you reduce this into? 2x squared over negative x squared. What could you reduce this into? 2x squared over negative x squared. What could you reduce this into? 2x squared over negative x squared. What could you reduce this into? 2x squared over negative x squared. What could you reduce this into? 2x squared over negative x squared. What could you reduce this into? 2x squared over negative x squared. What could you reduce this into? 2x squared over negative x squared. What could you reduce this into? 2x squared over negative x squared. What could you reduce this into? 2x squared over negative x squared. What could you reduce this into? 2x squared over negative x squared. What could you reduce this into? Well, you cross out the x squared, right? So that's how you have -2 over -1. And that is -2. Okay. Again, there's a reason behind all these numbers. Okay. So things do not just pop up for no reason. It's all because x is going to be huge. Okay. So that's the second bullet point. When the powers are the same. And now what happens when the power in the numerator is greater? Okay. Well, if that's the case, I mean, technically the horizontal asymptote is going to be y equals to infinity, which is way up there, and you're not going to see it. So we would just go ahead and say no horizontal asymptotes because it's so far away that we like in space, that kind of far away. Now, I also want you to write something down here. If that is the case, we actually have something else. It's called the slant asymptote, which you would not learn from me this year, but you will learn this in pre-calc. Okay, yeah, you will learn this in pre-calc. So slant asymptote. So you will learn this next semester when you take pre-calc. Okay, if you want to learn it, plenty of resources out there. I might have a video on my YouTube channel for this. Okay, so here are the main features. Okay, x and y intercepts, the two asymptotes, everything you find must have a reason behind it. I hope you are not just memorizing them. You're not just memorizing the actions. You know why you are doing the actions.